Hi, welcome to lesson 6.5, and we're going to talk about if we have a scatter plot, how to find a line of best fit. We're going to do it both by hand, and we're going to use a graphing calculator to create a linear regression. Okay, so sometimes, well, almost all the time, when we are looking for patterns in the real world, it's not a perfect line or a perfect parabola or whatever it is we're looking for. It's close to it. It follows a pattern, but it's not exact. And so we have to try and find the best model we can for that situation in order to make predictions. So as our example for today, we're going to look at a biologist who's studying trees, and the diameter in inches and the height in feet, and all of these are rounded to the nearest whole number so that they're a little bit easier for us to work with. So first we're going to make a scatter plot, which is just two variables we're comparing, and we put our points on there. So down here our independent variable is going to be diameter, and that's going to be in inches, and it looks like we can count by ones because we're only going up to 8. So 1, 2, 3, 4, 5, 6, 7, and 8. And then over here we're going up to 29, and I counted ahead of time, and this goes up to 14, I think, 14 lines. So I'm going to count by threes. So I've got height in feet, and then we're going to do 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, and 45. And then I'm just going to put the points on there. So I've got 2 and 8, and so 8 is going to be about 2/3 of the way there. 3 and 10, 1/3 of the way up there. 4 and 16, 5 and 17, 6 and 22, 7 and 20, and 8 and 29, like that. Now, I'm going to draw a line of best fit, and so you definitely need a straight edge for this. So if you don't have a straight edge, get one. It is helpful to have a clear straight edge. I'm going to use the protractor because it gives me I can see on both sides of it. And as a guide, I'm going to try and have as many data points above my line as below my line. So I'm going to go like right there, I think. So hang on. There we go. So I have 1, 2, 3 above, and 1, 2, 3 below, like that, and then one that's like exactly in the middle. So that works pretty well. And I'm going to go ahead and draw my line like that. So something to watch, sometimes students think that 0, 0 is a point, even if it's not. So if 0, 0 is a point, great, use it. But if you didn't actually put a point there, then it's not. Your y-intercept can be something different. So now we're looking at two ordered pairs that fall on our line. For me, I'm going to use this one was supposed to be on there. So 5, 17, and then 0, 3. And if you can use your y-intercept, it makes life a little bit easier. So in order to, I want to find my equation of my linear function, so I'm going to find my slope. So 17 minus 3, 5 minus 0, I'm using my y2 minus y1 over x2 minus x1 formula in order to find my slope. So 17 minus 3 is 14, 5 minus 0 is 5. So that's going to be my slope. And then here's where the calculations become really nice if you used your y-intercept. My y-intercept is 3. I can already see that, so I don't have to calculate for it. I can just say that my formula, or my linear function, is y equals 14 over 5 x plus 3, because 3 is my y-intercept. Now, I'm going to use that information, and this is the entire reason we have algebra, to find the find the patterns, which we did. We looked at our pattern, we found an equation, and then we're going to use that equation to make predictions. So we're saying, what if we have a height of, or what would be the height of our tree if our diameter is 14 inches? So x, our independent variable, is our diameter, so we're going to put the 14 in for x, so times 14 plus 3, and then I already put that into my calculator earlier, and I ended up getting 42.2, and that's feet. So that's how we use our patterns to make predictions. Okay, so that's one way to do it, is to do it by hand and kind of use some estimation. However, there are times when our calculators or computers or whatever, can be so much more accurate than us. And this is one of those times where we can get better information and better predictions by using computers. So that's what we're going to do here. We're going to, in our graphing calculator, put the same information that we had before. So this is going to give you kind of a step-by-step. I'm going to go through it with you while we look at the data, and then you can kind of use those notes there as a reference for later. So if you do not have a graphing calculator, go ahead and pause the video and grab yourself a graphing calculator. Come on back. Once you have your graphing calculator, you're going to push the Stat button, and we're going to be in Edit, so push 1 or Enter, and now it's going to put us in the lists, and we are going to put in list 1, we're going to put all of our coordinates for our independent variable. So I'm going to put 2 and then arrow down, and then 3, 4, 5, 6, 7, and 8, because those are the values I have for my independent variable coordinates. Okay, now I'm going to go back up to the top and arrow over to list 2, and in list 2, right next to my independent variables, I'm going to put the coordinates for my dependent variable. So when x is 2, y is 8. So I'm going to put 8, and then arrow down, 10, 16, 17, 22, 20, and 29. And don't hesitate to pause the video and catch up if you need to. So that's all we have right now. We have an independent variable and a dependent variable. Now we are going to do a linear regression to find our equation. So we're going to go back to Stat. This time we want the computer to calculate for us. So we're going to arrow over to Calc, and then we want a linear regression is what that stands for, and ax plus b, that's how they're saying mx plus b. I'm not sure why they're using a instead of m, but they do. So we're going to put, we can either arrow down to 4, or we can just put 4 and then enter, and it's going to give us our variables. So for our equation, we're going to use right here. So we're going to use y equals, and then instead of our m, we know our m, it's right here, and it asks us to round it to the nearest tenth. So we're going to do 3.2, because that 7 makes it closer to 3.2 than 3.1. So 3.2 x plus, and we're going to round that to 1.5. And so that is our equation using linear regression. It's also asking us to say what x and y is, just right here. So remember that x is the diameter of the tree, and that's in inches, and then y is the height of the tree, and that's going to be in feet. So that's going to help us when we actually use our equation. So right here, it says construct a table on our calculator. We already have a table on our calculator, so we're just going to use the equation we have. To the nearest tenth of an inch, which tree would be 45 feet tall. So 45 feet in height, that's our y. So instead of y, we're going to put 45, 3.2x plus 1.5, and now we solve our equation to find what the diameter of the tree would be. So that's going to be 43.5 equals 3.2x divide both sides by 3.2. And so our answer ends up being 13.6, and that's inches in diameter. So that's how you do a linear regression. One more thing to think about, it is good to think about what these things mean, the 3.2 and the 1.5. This is your slope. And so that means that how much the height grows in feet for every inch in diameter. So basically, according to this equation and the data that we have, every time your diameter grows 1 inch, your height is going to grow an additional 3.2 feet. This is kind of where we start. So that means that if we had a diameter of 0 inches, then we would have a tree of 1.5 feet. So that's not actually true. We can't really have a diameter of 0 inches, but that's the pattern that we see. Okay, please write down any questions that you have, and we'll talk about them next class.